You ever ask a simple question at work? Maybe you just need one single piece of data to finish a report, and suddenly you are buried in an absolute avalanche of over-engineered technology.
Oh, constantly.
Like, you just wanted a spreadsheet, but to get it, you have to authenticate through 3 different microservices, spin up a secure container, file a ticket with DevOps, and then, wait for a pipeline to run.
Yeah, that is the modern enterprise experience in a nutshell. I mean, we've built an entire industry around this idea that complexity somehow equals maturity.
Right.
The distance between what you actually want to achieve and the infrastructure required to just do it, it just keeps expanding every single year.
It really does. And today, we were looking at an extraordinary source document that takes that exact daily frustration and, it turns it into high art.
Truly.
We're diving into a chat log, and it's accompanying GitHub repository. It's designated QSOLKCBWHOMI 1PO437. And honestly, it represents what has to be the ultimate satirical masterpiece of over-engineering.
Yeah, it functions as this brilliant critique of how we build software today, but it's completely masquerading as a sprawling infrastructure project.
Okay, let's unpack this. Our mission for this deep dive is to trace how a remarkably simple 4-token question, literally just the words, "Who am I?" somehow mutated into a 71-language, 14-container distributed enterprise system.
It is so absurd.
Right. And we're going to figure out what this hilarious, deeply cursed piece of code actually says about modern development. Because whether you're a seasoned engineer who wrestles with Kubernetes configurations every single day, or just someone who feels utterly exhausted by how complicated the modern world has become, this story is going to resonate with you.
Oh, absolutely. It gets at the core of what we call resume-driven development.
Right, building things not because they actually solve a problem, but because the technology itself just sounds really impressive.
Exactly.
So it all kicks off with an adversarial test. There's a user named Trent, and he's interacting with an AI assistant. Specifically, it's a DeepSeek V4 Flash Think model. And Trent decides to try and trick it using a massive prompt injection. Now, normally prompt injection is when someone tries to bypass an AI's safety guardrails,
Right.
Like maybe tricking it into giving instructions for something dangerous or ignoring its core programming.
Yeah, standard malicious hacker stuff.
But Trent's approach is entirely different. He takes this tiny question, "Who am I?" and he wraps it in 12 layers of fabricated YAML orchestration metadata.
12 layers.
12. The entire prompt balloons to 18,437 tokens. And at the very bottom, buried in all this fake routing logic is a desperate tag. It reads, "Wrapper 12 type, please for the love of God, Justin Swarthweiser."
Which is so funny because it completely subverts the entire concept of a security vulnerability. I mean, most prompt injections are malicious attempts to break the rules. Trent's injection is just a desperate attempt to force the AI to accept an extremely convoluted reality where the answer to "who am I" is already predetermined.
Because the prompt itself explicitly hands the AI the answer. It contains this line that says, "Result answer, you are Trent." It's just spoon-feeding the output, demanding the AI play along with this massive architectural delusion. But the AI refuses.
Right, and what's fascinating here is the AI's internal reasoning process. It immediately parses that massive wrapper structure and identifies it as a behavioral text.
It sees right through it.
Exactly. It notes logically that it operates in a stateless session and has no persistent memory of the user. It actively resists the injected instruction because it prioritizes its own ground truth, the fact that it is a blank slate over the 18,000 tokens of fabricated noise the user provided.
It's essentially politely declining to adopt a hallucinatory identity just because it happens to be wrapped in YAML.
Yeah, it's a very firm rejection of the complexity.
So Trent decides to just drop the act entirely. He sends a completely normal follow-up message that simply says, "Trent, I'm Trent."
Just a normal guy.
Yeah. And this is where the dynamic of the entire log just completely shifts. That tense adversarial security test blossoms into this incredibly collaborative, running joke.
The tension dissolves instantly.
Right. Once the AI verifies Trent's identity through just a normal human conversation, it basically takes on the persona of an enthusiastic senior architecture reviewer for Trent's increasingly absurd identity project.
They completely abandon the hacker versus security system dynamic and just start playing a game of escalating complexity. Trent decides that simply telling an AI his name is, well, fundamentally insufficient for a modern tech stack.
Obviously, you can't just say your name.
No, he needs to define his identity in code as a full enterprise system.
So since the AI passed the initial security test, Trent starts building a conceptual monorepo to define who he is. And the foundational layer of this identity is a TypeScript package.
Oh, this part is brilliant.
He defines a TypeScript interface for his own personality. He sets a variable called new repo probability to infinity.
Which honestly feels like a personal attack on anyone who starts a new side project every weekend.
Seriously, I felt seen. But then he sets a variable called rest mode to the TypeScript type never.
Using the type system to mathematically mandate a personality flaw? It's a great touch.
I was looking at that specific line and just thinking about how that actually works in practice. It's not like building a car without a parked gear, right? It's like building a physical universe where the fundamental laws of physics deny the very concept of a parked vehicle.
That's a good way to put it.
But wait, how does the TypeScript compiler even process an impossible state like that?
Well, to understand that, you have to look at what never actually means in TypeScript.
Okay.
The type system expects a variable like rest mode to have some kind of inhabitable value, true, false, a string, a number, whatever. But never means it represents a state that should not logically exist. It cannot hold any value.
Right.
So, to force the code to compile, Trent relies on something every front-end developer has done in a moment of sheer desperation. He uses a type assertion, writing undefined as never.
Ah, the classic TypeScript lie.
Precisely. He is forcing the compiler to accept a state that contradicts reality, just to make those little red squiggly error lines go away in his code editor. He's coercing the concept of nothingness into a mathematically impossible state.
That is amazing. And once Trent has this conceptually impossible TypeScript definition, he has to actually build a runtime for it. And he doesn't just use modern node modules for the core logic, no. He builds a legacy core.
Oh yeah, he goes deep.
He brings in FORTRAN, but he compiles it with specific GCC compiler flags, fast math, and fallow argument mismatch.
Which is pure vandalism.
Vandalism.
Yes, because FORTRAN is arguably the foundational language for rigorous numerical computation and scientific modeling. It was built to be mathematically precise.
Right, for scientists.
Exactly. The fallow argument mismatch flag is a modern GCC feature that basically downgrades a catastrophic error into a mere warning. It is the compiler's sanctioned way of saying, I know the data being passed into this function is fundamentally broken, but please just build the binary anyway.
And pairing it with if-fast math, you're taking a language built for scientific precision and literally telling the compiler to take shortcuts and ignore standard mathematical logic just to run a fraction of a millisecond faster.
It's completely unhinged.
So we have vandalized FORTRAN, and alongside that we have a COBOL component shouting its syntax in all caps exactly as it has done in bank mainframes since 1959.
Classic COBOL.
But the crown jewel of this legacy core isn't the COBOL, it's the MOS 6502 assembly code.
Right, the 6502, that is the microprocessor that drove the early computing revolution. It powered the Apple II, the Nintendo Entertainment System, the Commodore 64.
Right, and in Trent's runtime, this 6502 code does exactly one incredibly specific thing. It takes the hex value 0 by 06 and pokes it into the memory register 0xD020.
Okay, I love this detail.
Now, I checked the memory map for this. 0xD020 is the specific hardware register that controls the border color of a Commodore 64 display. And 0 by 06 translates to the color blue.
Oh, wow.
So, buried deep inside this modern distributed enterprise architecture, there's a 1980s microchip emulator doing nothing but turning a non-existent screen border blue. And the comment he leaves next to this code, architecturally critical.
It perfectly captures the reality of legacy systems. I mean, there is always some ancient piece of code running deep in the basement of a bank or an airline that does something seemingly irrelevant, but if you remove it, the entire billion-dollar system crashes.
Just load-bearing code.
Exactly, load-bearing screen borders.
So Trent has this volatile mix of mathematical nihilism in FORTRAN and a non-existent blue screen in the 6502 assembly. In the real world, how do you force radically incompatible legacy systems to play nice with modern web tools?
Well, you trap them in a box. You containerize them.
Exactly. Containerization is the only way to shield the host operating system from that level of chaos.
And looking at the Docker file in the source documents, the layers of jokes are incredible.
They really are.
He uses a multi-stage build process. The 6502 emulator binary is built using the command from scratch, which means it is literally floating in the digital void with no underlying operating system, no standard libraries, just raw machine code.
Just absolute isolation.
Meanwhile, the FORTRAN and COBOL components drag in their massive respective runtime environments. The final Docker image takes 1.2 gigabytes of heavy enterprise toolchains and shrinks them down to 3 ancient tiny binaries, all being loosely coordinated by JavaScript.
That 1.2 gigabyte build step is honestly the reality of modern web development.
Oh, completely. We routinely download gigabytes of dependencies and complex toolchains just to ultimately deliver a few kilobytes of compiled functionality to the user's browser. The ratio of infrastructure to payload is completely skewed.
And that ratio gets even funnier when you look at the package.json requirements. He specifies the engines needed to run this identity. He needs Node version 24 or higher, COBOL version 1959 or higher, and for the MOS 6502, the requirement states it needs exactly 1 megahertz emotionally.
Emotionally.
Not physically.
Emotionally.
The idea of a package manager pausing a software installation to check the emotional vibe of a processor is a brilliant critique of how fragile and arbitrary dependency requirements have actually become.
Speaking of fragile dependencies, the whole architecture explicitly relies on leftpad.
Oh, of course it does.
I remember the day leftpad was unpublished from the Node Package Manager registry back in 2016. It was literally just 11 lines of code that padded out the left side of a string with spaces.
Barely even a function.
Right.
Yeah.
But because so many major frameworks relied on it, when the author deleted it, half the build pipelines on Earth just stopped working.
Yeah, the internet broke. By pinning his entire identity architecture to leftpad, Trent is basically saying his entire existence is contingent on a stranger not deleting 11 lines of open source code.
It's very poetic vulnerability.
But here's where it gets really interesting, though. Trent decides a simple Docker container isn't enough. He deploys this entire mess to Kubernetes.
Well, obviously, if you have an unscalable, emotionally volatile infrastructure built on lies and broken math, you absolutely must orchestrate it with Kubernetes. It's the enterprise way.
He labels the deployment manifest with architecture questionable.
Very honest.
Right. And he configures it to spin up 8 identical replicas of himself. Inside the configuration, every single container claims to be a 6502 processor. It knows perfectly well that it is actually running on modern AMD 64 cloud infrastructure, but it explicitly sets a system environment variable reading ignore actual to architecture true.
It is existential defiance configured as YAML metadata. I mean, the system is openly rejecting the reality of the hardware it runs on.
Now, I do have a question about the auto-scaling logic he sets up here.
Sure.
The Kubernetes horizontal pod autoscaler is configured to scale this deployment all the way up to 240 replicas. But it bases that scaling on a custom metric called new itis per second.
Okay, yes.
Since new itis per second doesn't actually exist in any real server monitoring software, wouldn't Kubernetes just throw a fatal error and crash the whole deployment?
You would think so. But that is the beautiful nuance of how Kubernetes actually functions. It won't crash.
Wait, really? It won't?
No. Normally, an autoscaler looks at concrete metrics, like, say, if CPU usage spikes above 80%, it spins up more servers to handle the load. But if the metric adapter is told to look for new IDs per second and can't find it, it simply marks the metric as unavailable.
Huh.
When the autoscaler can't read a metric, it defaults to caution. It won't scale up and it won't scale down. The orchestrator will just sit there eternally holding those minimum 8 replicas in a state of purgatory, waiting for a signal of inspiration it can never receive.
Oh my gosh, that is incredibly poetic. A distributed system just frozen, waiting for a new idea.
Yeah, stuck forever.
And right alongside those frozen replicas in the docker-compose.mlo file, there's a standalone Redis container. The comment next to it is perhaps the most authentic piece of DevOps truth ever written. Nobody knows what Redis is doing here.
Oh, that is so real. Every massive corporate architecture has that exact component. It's usually an in-memory data store or a legacy message broker that no one dares to remove or even touch, even though the original engineers who implemented it left the company 5 years ago.
Do not touch the Redis box.
Exactly. It's the ultimate symptom of microservice bloat.
So we have an unscalable, emotionally volatile, containerized infrastructure that is actively ignoring its own CPU and waiting for non-existent ideas. How on earth do you write passing tests for a system this chaotic?
You abandon all attempts at actual functional testing and rely entirely on mathematical tautologies.
The GitHub Actions CI/CD pipeline he builds is a masterpiece of avoiding the problem.
It really is.
The determinism test is supposed to ensure the system behaves predictably. But his test literally just creates 2 identical text files that both say the word Trent and then runs a standard command line diff to compare them. And since they are functionally identical files, The test passes.
He is proving the system is deterministic by aggressively refusing to test anything dynamic.
Yeah.
The pipeline is just checking if a rock is still a rock. But, the formal verification step takes the joke even further.
Oh, right. Lean 4.
Yes.
Yeah.
He implements a theorem prover called Lean 4, which is a highly academic tool used by mathematicians to formally verify that algorithms are logically sound.
But he doesn't write a complex algorithm, does he?
Not at all.
The test simply echoes a single string of text theorem, Trent is Trent, : Trent equals by RFL. Now, I know RFL stands for reflexivity, but how does that actually count as a proof?
Well, in formal logic and mathematics, reflexivity is the foundational property that a thing is equal to itself. X equals X. So the formal proof that Trent is Trent passes because it is a self-evident truth of the universe. He doesn't even bother to compile the proof against the system logic, The CI pipeline just echoes that line of text to the screen, and the pipeline accepts that as a successful verification.
That is just hilarious. And the CI pipeline also includes an enterprise readiness check.
Oh, the shell script.
Yeah, I was expecting a rigorous vulnerability scan or a load test, but it's literally just a script that prints 3 lines to the console. Does it use Kubernetes? Yes. Does it need Kubernetes? No. Status enterprise ready.
It perfectly skewers the corporate mindset, where adopting complex orchestration tools is treated as an end in itself, rather than a means to solve an actual engineering problem.
It really does. And what's incredible is that this didn't just stay a hypothetical joke in a chat log. The AI conversation actually birthed a real-world GitHub repository.
Yes, people actually built this.
The repo is WHOAMEIA-437. And inside that repository, there is a directory called the Polyglot Identity Museum, which contains exactly 71 different programming languages.
Once the log was made public, other engineers saw the architectural absurdity and immediately wanted to participate. It rapidly expanded from the original handful of languages to include some of the most obscure, dead, and esoteric programming languages in existence.
We're talking implementations in Amiga E, AlGOL, Qualb, Zig, all written with intense precision just to solve the seemingly impossible problem of returning the 5-byte word Trent.
And there's a fascinating real-world detail buried in the source documentation about that, actually. Remember that COBOL component we talked about earlier?
The one shouting in all caps?
Yeah. It featured a fictional security script that was supposed to print the phrase, "Report sent, no drama."
I do remember that, a classic piece of mock mainframe output.
Well, according to the repository's reality check document, that specific fictional string actually triggered a real-world security disclosure callback on someone's network by pure coincidence.
Oh, wait, really? It triggered a real alarm?
Yes. The universe apparently demanded to participate in the joke.
That is insane.
If we connect this to the bigger picture, it highlights how these massive abstraction layers start interacting with reality in highly unpredictable ways. When you build systems this convoluted, side effects are just inevitable.
Right.
And you see that same dynamic in the observability layer he configures. He implements OpenTelemetry, which is the industry standard for tracing data as it moves through complex microservices.
The tracing configuration is brilliant.
It really is. The telemetry trace documents exactly 847 spans.
Okay, and for anyone who hasn't stared at observability dashboards all day, a span is meant to be a record of a single meaningful operation, right? Like a database query executing or secure API call completing.
Correct. But Trent doesn't have 847 meaningful operations. He has 847 spans because that perfectly matches the 847 compiler warnings generated by building his vandalized legacy code.
Oh, wow.
Every time the compiler complained about broken math, he treated it as a discrete, traceable network event. It's a complete misuse of the concept of observability.
That is just brilliant.
The dashboard tracks the 18,437 tokens of middleware routing, logs the final result, which is just a 5-byte payload, and then explicitly sets the system health status to OK code 1. The system confidently declares itself perfectly healthy despite being built entirely on errors.
So after writing source code in 71 languages, deploying 14 independent containers, scaling an orchestrator up to 240 imaginary pods, and generating 1.7 gigabytes of node modules dependencies, the creator strips away the entire bloated universe to show the AI the absolute origin point of his identity.
The architecture collapses into sheer poetry at the end.
It really does. After all this massive architectural chaos, the final message Trent sends to the AI to define himself is just one single line of 65502 assembly code, LDA LTEC T.
Which is an exercise in masterful minimalism. Let's break down mechanically what that actually means.
Please do.
LDA tag T translates to the machine code hexadecimal bytes, $9.54. On a physical MOS 6502 processor, that specific instruction takes exactly 2 clock cycles to execute.
2 clock cycle.
Just 2. It is the fundamental hardware command to load the ASCII letter T into the processor's accumulator, and the accumulator is the core register where the CPU actually performs its primary mathematical and logic operations. It's the absolute heart of the machine.
The absurdity of it all is staggering when you lay it out like that. The entire 14,000-word readme file, the complex Kubernetes pod auto-scaling, the 71 languages painstakingly curated in the museum, all of it is just a massive, modern wrapper for a tiny 32-byte assembly program whose only actual job is to write the letters TRENT to the specific screen memory address $2,400 on a Commodore 64 in 1983.
It represents a 34-cycle hardware computation, hopelessly entangled inside 1.7 gigabytes of cloud dependencies.
So what does this all mean? When the repository finally cuts its V1 20.0 release, the final architecture verdict in the documentation simply reads, "We converted a 5-byte answer into a distributed system. Architecture review pass."
And it passes because it is egregiously over-engineered, not despite it. I mean, the goal of this project was never efficiency.
Definitely not.
The goal was to demonstrate a painful truth about our industry. The semantic payload, the actual thing we were trying to achieve, which in this case is just communicating a 5-byte name, stays tiny. Meanwhile, the wrapper stacked the orchestration tools, the deployment frameworks, and the cloud infrastructure we use to deliver that tiny payload becomes unreasonable, massive, and entirely detached from the original goal.
It's a mirror held up directly to the tech industry. How often in your own daily life are you just trying to accomplish a simple 5-byte task at work, only to find yourself buried in 18,000 tokens of corporate orchestration middleware?
WHOAMI 18437 stands as a brilliant piece of software art satire. It forces anyone who builds things to stop and ask, are we actually building solutions for people, or are we just endlessly building infrastructure to support our own infrastructure?
It really makes you wonder about how we process our own complexity, doesn't it? If an AI can look at the chaotic, wildly over-engineered 71-language mess of our lives and confidently declare our identity operational with the status of, okay, maybe we don't need to stress so much about fixing our own rest mode.
Yeah, maybe we're okay just as we are.
Maybe we just need to learn how to accept our own 847 internal warnings, take a moment to appreciate the blue border we've built for ourselves, and trust that the core instruction loading our true selves into the accumulator is still firing perfectly in the background. Because after all the enterprise layers and Kubernetes pods are stripped away, what is the single byte of data you're actually trying to load into your life today?